Welcome back, everyone. Today we're going to be diving deep into the world of machine learning. But, not the algorithms themselves. This time we're focusing on something even more fundamental.
Oh, I like where this is going. You're talking about the data, right?
Well, yeah, but more specifically, the individual pieces of information that algorithms use to learn and make predictions. Those are called features.
Features, yeah, those are critical. Without the right features, even the most sophisticated algorithm is going to be useless. Kind of like trying to build a house without, any bricks or beams.
I see what you mean. So in that analogy, the features are like the raw materials, the building blocks.
Exactly. Each feature represents a specific characteristic or attribute of the data. If we stick with that house analogy, you could think about things like the size of the house, the number of bedrooms, the location, all those are features.
So when we talk about features in machine learning, we're really talking about translating real-world stuff into something an algorithm can understand, right?
You got it. We're giving the algorithm a set of blueprints to work with, so to speak.
Makes sense. But here's a question. If we're giving an algorithm all this information, wouldn't it make sense to just throw as much data at it as possible? The more the merrier, right?
Well, not necessarily. More data isn't always better. In fact, sometimes it can actually hurt the model's performance.
Huh. Okay, now I'm really intrigued. Tell me more.
It's all about finding the right data, the most relevant features. Too many features can actually lead to something called overfitting.
Overfitting, what's that?
Imagine you're teaching a kid to recognize different types of fruit, right? You show them 100 pictures of apples, all shapes and sizes. They might start to think anything round and red is an apple.
Oh, I see. Then you show them a strawberry and they're totally lost.
Exactly, that's overfitting. The model has become so focused on the specific details of the training data that it can't generalize to new examples.
So how do we prevent that? How do we make sure the algorithm is learning the right lessons?
That's where feature engineering comes in.
Future engineering. Sounds fancy.
It might sound complicated, but it's really about being smart about the features we choose and how we present them to the algorithm. It's about transforming those raw features into something even more insightful. Like, instead of just giving the algorithm the number of bedrooms and the square footage, we could create a new feature called average room size.
Ah, that's clever. So you're saying it's not just about feeding the algorithm raw data, it's about being creative and finding those hidden gems, those features that really tell a story.
You're getting it. Feature engineering is all about crafting the best possible tools for the algorithm to work with.
Okay, this is blowing my mind a little. So we've got this whole process of carefully selecting and engineering features to make sure our algorithms are learning the right things. But how do we know which features to focus on? I mean, there could be hundreds, thousands, even millions of potential features to choose from, right?
Absolutely, and that's where feature selection comes into play. It's all about identifying the most relevant features and getting rid of the ones that might be redundant or even misleading.
Okay, that makes sense. But how do we actually do that? How do we sift through all that data and find the golden nuggets?
There are tons of different approaches, but one common starting point is to look for correlations between features. Like, if we're trying to predict housing prices, we might have one feature for number of bedrooms and another for total square footage.
And those two are probably going to be pretty closely related, right? A bigger house usually means more bedrooms.
Exactly. So we might not need both of those features. Keeping both would just add noise and complexity, which could actually hurt the model's performance.
It's like giving someone two sets of directions to the same place. It just gets confusing.
Perfect analogy. The goal of feature selection is to simplify the model, improve its efficiency, and prevent that pesky overfitting we were talking about.
So it's kind of like decluttering, but for data.
Yeah, exactly. And there are various techniques we can use to declutter our features, everything from simple correlation analysis to more sophisticated methods like using tree-based models. But we'll save this for another day.
Sounds good. But hold on, I have one more question. Let's say we've done all this amazing feature engineering and selection. We've got this perfect set of features all ready to feed to our algorithm. Is there anything else we need to consider?
Yeah, actually, there's one more crucial step: feature scaling.
Feature scaling. Now, what's that?
It's all about making sure that all our features are contributing equally to the model. You wouldn't want one feature to have more influence just because it's measured on a different scale, right?
Like if we're predicting house prices, we wouldn't want the number of bathrooms feature to outweigh the square footage feature just because the numbers are smaller, right?
That's exactly right. That's where feature scaling comes in. It levels the playing field by bringing all the features to a similar scale.
Ah, so it's like making sure everyone has an equal voice, regardless of how loud they can shout.
I love that analogy. There are a couple of common techniques we use for feature scaling, like min-max scaling and standardization. But again, we can delve into those later.
Okay, this is all starting to click into place. So we've got feature engineering, feature selection, and feature scaling, all these crucial steps to prepare our data for the algorithm. But I'm curious, does the type of algorithm we choose also influence how we approach feature handling?
Absolutely. Different algorithms have different strengths and weaknesses, and some are more sensitive to the scale or distribution of features than others.
So it's not just about prepping the data, it's about understanding how that data interacts with the specific algorithm we're using.
Precisely. Choosing the right algorithm is like picking the right tool for the job. A hammer is great for nails, but not so much for screws.
So we need to consider both the data and the algorithm when we're doing all this feature engineering and whatnot.
You got it. It's all interconnected. But I think that's a good place to pause for now. We've covered a lot of ground already.
That's true. We've gone from what features are to how to select the best ones, how to engineer even more powerful ones, and how to scale everything so it plays nicely together. And we even touched on how the algorithm itself influences our approach.
Phew, that's a lot to digest.
It is. But I feel like we've only just scratched the surface. There's still so much more to explore in this fascinating world of feature engineering. But for now, we'll leave our listeners with that thought. We'll be back soon to delve deeper into some specific techniques and approaches.
And we'll tackle some of those burning questions you've got brewing, I'm sure.
Exactly. Until then, keep those brains buzzing.
And happy feature engineering. You wouldn't want to use a saw to hammer in a nail, right? Each algorithm has its own strengths and weaknesses, and they might need different kinds of features.
So it's not just about prepping the data, it's about understanding how that data interacts with the specific algorithm we're using.
Exactly. And there's another layer to this whole feature thing.
Oh, let me guess. More complicated than we thought.
Maybe a little. We need to think about the context, the specific problem we're trying to solve.
So like the bigger picture.
Yeah. If we're building a model to, let's say, predict customer churn for a streaming service, features like viewing history and engagement metrics would be way more relevant than, their favorite ice cream flavor.
Okay, yeah, that makes sense. It's like using the right spices for a dish, right? You wouldn't put chili powder in a chocolate cake.
Exactly. You need to choose features that align with the specific problem you're trying to tackle.
So context is key. Got it. But how do we actually see these connections, these patterns in the data? It can't all be intuition, right?
Intuition plays a part, but we also have some powerful tools at our disposal. Data visualization can be a game changer here.
Data visualization. I'm intrigued. Tell me more.
Think of it like having X-ray vision for your data. Tools like histograms and scatter plots allow us to actually see the data, to spot trends and relationships that we might otherwise miss.
So instead of just staring at rows and columns of numbers, we can actually see the data come alive, right?
Yeah.
That's super cool.
It is. Data visualization can help us identify outliers, those data points that are way off from the norm. Sometimes outliers are errors that we need to fix, but sometimes they can actually point to valuable insights that we wouldn't have noticed otherwise.
Oh, that's interesting. So outliers aren't always bad.
Not necessarily. Sometimes they're the key to unlocking something really important, but yeah, data visualization helps us see all of this more clearly. It's like having a map to navigate the complex landscape of our data.
Okay, I'm starting to see how all these pieces fit together. So to recap, we need to understand the problem, pick the right algorithm, select and engineer the right features, scale them appropriately, and then visualize the data to make sure everything is aligned.
You got it. It's a multifaceted process for sure.
But it sounds like there's no one right way to do it, right?
Yeah.
Each problem is unique, and we need to be flexible and adapt our approach.
Exactly. Feature engineering is all about experimentation and iteration. You try different things, see what works best, and learn from your mistakes along the way.
So it's a process of continuous learning and refinement.
Absolutely. The more you experiment, the more you'll develop that intuition I mentioned earlier. And that's what makes it so exciting. There's always something new to discover.
I love that. It's about embracing that sense of curiosity and never being afraid to try new things. So final thoughts for our listeners as we wrap up this part of our deep dive.
The key takeaway here is that feature engineering is the heart and soul of machine learning. By mastering this art, you're unlocking the true potential of your data and empowering your algorithms to make accurate predictions and uncover those hidden gems of insights.
Beautifully said. It's all about giving our algorithms the best possible tools to work with so they can do their magic.
Exactly. And who knows what amazing things you might discover along the way.
It really feels like we've opened up this whole toolbox of techniques for getting the most out of our data.
We have. And like with any toolbox, the more you practice using the tools, the better you become at wielding them.
I like that analogy. So for someone who's just getting started with machine learning, what's the best way to start practicing these feature engineering skills?
The best advice I can give is to just dive in and get your hands dirty. Start experimenting with the different data sets, try out various feature engineering techniques, and see what happens.
So embrace that beginner's mindset, that willingness to experiment and make mistakes.
Exactly. Don't be afraid to break things, to try things that might not work. That's how you learn and grow as a machine learning practitioner.
And remember, even the experts are constantly learning and refining their approaches. There's always room for improvement and new discoveries to be made.
You got it. Machine learning is a constantly evolving field, and that's what makes it so exciting. There's always something new to learn and explore.
Well, I think we've given our listeners a fantastic overview of the power of features in machine learning. We've covered everything from the basics to some pretty advanced concepts, and I hope they're feeling inspired to start building their own amazing models.
I hope so too. And remember, the journey of machine learning is all about exploration and discovery.
It's about pushing those boundaries and seeing what's possible.
Absolutely. And who knows what incredible breakthroughs you might stumble upon along the way.
As we wrap up our deep dive into the world of features, I'd like to leave our listeners with one final thought to ponder. If features are the building blocks of machine learning, what kind of world will you build with them? The possibilities are truly endless. So go out there, experiment, explore, and build something amazing.
Couldn't have said it better myself. Keep learning, keep creating, and we'll see you in the next episode.
Happy feature engineering, everyone.